Now the wide angle camera's messed up. Oh well. Resonance Radio episode, who knows what, who cares?
We should talk about some ideas.
Keith Witten, welcome to the Resonance Radio studio. My name's Thomas Spellman, host.
Nice to be here.
Host of the Resonance Radio podcast. We were talking about all sorts of things earlier. Unfortunately, we didn't have the cameras rolling.
Right.
But we both have been raving about the recent interview with Nassim Haramein on the Mystify Sci podcast.
Yeah.
Wow, Nassim Haramein's been making waves.
And what's interesting is both you and I somewhat guiltily wrote that guy off, or not wrote him off, but we certainly misjudged him to a certain extent, or misjudged his work, or what we know about it anyway.
Yeah. I mean, I think for myself, I had limited ability to judge his work, given that there was a lot of math involved, and I'm not versed in that level of math, so it's, I was limited to just the perception of the story combined with kind of circumstantial stuff. Like, when he published one of his papers, I did some looking into the journal and the peer review process, and it just seemed to be, to me, not the most reliable, trustworthy peer review journal type situation. And so that kind of gave me some pause. And so the combination of things, it was like hard to say, but I do remember loving his idea of, on the scales thing, like in the one idea, we're like, it's like we're inside of the event horizon of a black hole looking out. Like when we look out into the universe, it's as if we're looking out of an event horizon of a black hole. And when we look into the micro, the proton has characteristics of like what it would be like looking at the event horizon of a black hole from the outside. So that one idea I do remember getting from his story, and just that thing of we can see about, it wasn't just him, but we can see about as far outward in terms of scale as we can see inward into the micro.
Yeah, it's another way of understanding
a lot of people have talked about that as well, but yeah, recently, like on that, I think on that podcast recently, the Mystify Sci, it's always kind of a tongue twister. Demystify Sci. I mean, I personally think we both, this might be where we are more similar and different than them, is we actually, I think, really enjoy and appreciate the mystical side of reality, maybe more so than the scientific, numerical, mathematical,
In fact, you were talking about that it would be nice to get Nassim on this podcast.
I mean, that would be amazing. I would love to.
Of course, yes.
There's so many things, and we've talked about some of them that some of the stuff we've talked about that's more in the cosmology and just the more scientific end of the spectrum. I'd love to riff with him about.
I'd like to go in the other direction.
Yeah.
So talk about his mystical path.
Right.
And some of the different thoughts that he has, about that.
Right.
Instead of hard science, or they don't have to be on one side of the line, but anyway, that would be
right.
A very interesting conversation also.
And I mean, historically, it seems like he was willing to go in those directions.
Well, it's very clear that this is a man who's got a deep spiritual background.
Yeah.
No doubt.
I mean, I would hope that now that his hard science side of his work is beginning to be recognized, will he be less inclined to do the woo-woo mystical? I don't get that sense from him. I get the sense from him that he's never been willing to limit the scope of what he's. And we're going to reserve that for resonance. Oh, I said it.
Yeah, right. Ideas that resonate.
Ideas that resonate. Well, there was something that you were saying that was coming up for you that you wanted to talk about, that talk out? Yeah.
Well, yeah, you mentioned Demystify Science.
Yep.
And they have this new feature of paradigm drift,
Mm-hmm.
is what they call it, where they um, solicit people to present their ideas on a podcast for 1 minute,
Mm-hmm.
which 1 minute is just like the most ambitious time ever to
Yeah.
be able to get across an idea. But then the idea, they're 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 saying that if within a minute even just a little bit comes clear, they
Mm-hmm.
would then dig into that possibly in a full podcast,
Yep.
if it warranted it.
If it seems like there's a there.
Yeah, if it seems like in a minute enough has gotten across that they go, okay, this guy's got something at least. Maybe you didn't fully elucidate it.
Mm-hmm.
So, and I just thought that their process. I wrote down. They have a website where you can go there and you can apply, and I applied for this thing.
Mm-hmm.
And they say that they want you to explain 3 things, and the 3 things that they want you to explain. I thought that we could talk about and sort of work out what would be discussed, and then try to condense it down to that 1 minute
Mm-hmm.
sort of idea. And so first they want you to explain what the problem is and what your theory or paradigm is addressing.
Mm-hmm.
So what's the problem, and how does this new paradigm or the new theory address that or fix that problem? And then how solving that problem changes the world going forward.
Mm-hmm.
So those 3 things are...
That should be 3 minutes, at least 1 minute for each one of those.
You got like, what is that, 20 seconds for each
Yeah,
one of those?
right? What's the problem? 20 seconds. Keith, go.
Tough, man.
3, 2, 1, go.
Right. But, yeah, so, okay, let me give you my best effort.
Yeah, that was
You got- you
only
got a
half
minute?
joking.
You got a
All right.
second hand there?
Let's see. Let me grab my phone. We're gonna pause. Okay. I've got the stopwatch ready. Ready?
When I start?
3, 2, 1, go.
Okay, so the problem is that we're looking at the solar system wrong. We're looking at it as a mechanical structure when actually it's a living structure. And how my theory addresses the problem is it looks at it holistically, because you have to include also the observer of the thing that you're observing, and that's us. And we live in a biosphere, and the biosphere is existing on the heart planet, but it also requires the sun to power the life on the heart planet. So you have to consider the whole of the solar system as a living being. And if you then do that, then you're able to incorporate consciousness and an interaction with yourself and the solar system and the other, which is what I refer to as being the totality of the self.
57 seconds. Bam.
Not bad.
Yeah.
I don't know if what I said made
I followed it, but
you
I might
because we
be
had a lot of
biased.
conversations on that. But that
Yeah,
is-
well done.
that's the basic idea, is that somehow it's like we're looking at things wrong, that it's a living system.
Yep.
And what really is what I want to be able to get across also in that is that there's been this confusion of it's like the Gaia hypothesis. The original Gaia hypothesis was, I think, an effort to deal with the holism characteristic of human bodies don't exist apart from the atmosphere that they grow up in, right, or that they exist within. This is what Lovelock understood when he was assessing the atmosphere. The atmosphere and the living organisms that produce the atmosphere are part of a whole. But where he went wrong, or where he didn't go far enough, was to recognize that the Earth itself is not whole. It's like it's not an organism. There's different levels of wholeness, is the way that I look at it. So there's the wholeness of an organism, but then there's also organ systems within that organism.
Mm-hmm.
And the Gaia theory confused the Earth
which is one organ of a larger
It's
system.
an organ system.
Oh, it's an organ system
Of an organism.
of an organism.
It's like the organism is the solar system.
Right.
The Earth itself is the heart planet, which is like the heart. The heart is not an organism.
Mm-hmm.
It's an organ system within the organism of the greater body.
And also, you've also described it as it's not just this disembodied heart all by itself. The heart and lungs and the blood, oxygen, yeah,
forms a gradient across of arterial blood and venous blood and left and right, and yeah, it's a living system.
It's an organ system. Like when you say organ system, even just the heart, it's itself a system of something going on. It's not just an organ, isolated.
You can't just extract the heart from the body and keep it alive.
Right.
It's the living quality that requires it be a system.
And it's the integration between it and the whole rest of the whole body.
The whole body. Yeah.
Right.
And specifically in terms of, the Earth is the heart planet. And this is where you start to have trouble getting in all this stuff within a minute.
Right.
Because you have to talk about complementarity.
Mm-hmm.
And the solar system is a photosynthetic organism, whereas we are respiratory organisms.
Mm-hmm.
And so it's complementary in the sense that we use oxygen in the same way that plants use light. So and the light, of course, comes from the sun above, and that light is involved in driving photosynthesis of plants, but it's also involved in driving the circulatory system, which is the hydrologic cycle. And then it's also involved in the magnetospheres. The Earth has a magnetosphere which protects the biosphere from the rays of the sun, the solar wind. Without a magnetosphere, the biosphere would be wiped out. But even more than that, the magnetosphere is what I refer to as a part of the morphogenetic field of the solar system as a whole. So it's not just the Earth's magnetosphere, but all of the magnetospheres, including the heliosphere, are part of the awareness of the solar system. It's like the magnetosphere is what I think of in terms of like a visual representation of a tuning fork. One tuning fork goes off if it shares the same wavelengths, then it'll resonate with the other tuning forks. And so these are like complex tuning forks, and it establishes a awareness of consciousness basically throughout the solar system. So all of these factors need to be accounted for in terms of this is what a living solar system, the structure of it entails all of these pieces. But the heart planet has to include the sun, also the breath, it's like the breath is the moon, which includes the tidal forces, but also the phases that the moon goes through relative to the sun. And those phases are having an impact on photosynthetic plants during the dark, below the circle of illumination. So, yeah.
Cool. Well, I think you nailed it in 57 seconds. So I think, everything else you said, I think stems from that. But I mean, I think you got the gist of it in there. I don't think you need to, I don't think you need to worry too much about like that. Everything else you said took about 7 minutes or maybe, like, there's more and more. Obviously, the book isn't even enough to fully explain it. So there's that problem of scale. You gotta,
I just worry about the fact that, like you said, you've heard all this before. So you're in a certain sense. Let me read you this. We were talking about paradigms also, and this is a book by David Bohm and David Peat.
Can you hold it like right here towards this camera?
Oh yeah, towards that one. And David Bohm is probably one of my favorite, one of my top 3 scientists. I got about 10 top 3 scientists, but he's definitely one of them. And This is he's talking about paradigms, and he says that scientists, for example, may avoid confronting deeper ideas by assuming that each particular difficulty or contradiction can be dealt with through some suitable modification of a commonly accepted theory. Each problem therefore produces a burst of activity in which the scientist seeks a new idea. But rather than looking for something truly fundamental, scientists often attempt an addition or modification that will simply meet the current problem without seriously disturbing the underlying infrastructure. Right?
Mhm.
So it's like I say my 57 seconds and I wonder what they're actually hearing.
Yeah.
It's like, are they going to hear that? It's like.
But, yeah, I guess that question then gets to who's your audience there? Really, your audience there, like who? So the 1 minute, right?
Yep.
You're motivated to do that. I mean, intrinsically, because the 1 minute is intrinsically valuable to get your 1 minute, right?
Yep.
But it's also a chance to have a bigger conversation, right?
Yes.
And that's a big reason why you're doing it. You're doing it maybe even more for the possibility of having the larger conversation.
Absolutely. That's what I want.
And who decides that? Is it democratic vote of all the listeners? No.
It's the two.
It's the two.
Yeah.
So who are your audience?
Those guys. The two.
Those two. So
yeah, that's a good point.
So what symbols, what language, what paradigm, what way of framing it, based on the limited degree to which you've listened to them and know what their perspective is and what they're tuned into and how they're gauging, whether something is interesting, worth looking into more, right?
Yeah. They seem to be very open-minded, actually, and looking for a deep understanding of. It's like I think they're open to questioning their paradigms. Yeah.
They are, while at the same time, it seems like they are also extremely well versed in granted, the cutting edge, but still the cutting edge of like theoretical physics. Yeah.
Yeah.
Very much like they are discovering Nassim at a point at which his mastery of the mathematics and the language of framing his ideas in the theoretical physics language and tools and is to the point where it's able to be understood by people very much in that world.
Yeah.
And so I guess I'm saying that because, like, yes, they're open to having their paradigms, to new paradigms, but they're very, like, most comfortable in that theoretical physics domain. So
this is kind of a biology domain, but I get the sense that they're. I mean, I guess I don't even know their backgrounds enough to comment, but
yeah, nor do I.
Yeah,
This is just based on watching a few of their podcasts and like what the kind of the things that the kind of questions they're asking.
Yeah,
like it seems like they're trained in theoretical physics, that really sophisticated math and all that kind of stuff, but they're also like, my sense is they're wanting to make it tangible. They're like, their questions are often about over and over and over. I've heard them question like particularly in waves of what, the electromagnetic waves are waves of what? What is the it that's waving?
Yeah.
That's a question they've asked a few times.
Yeah, I remember that. Yeah.
And with Carver Mead too, that came up. So it's like they were talking about the electron, right? And so the electron has frequency and vibration, but what's frequencing? And you're like, well, there's this something that fills the space, and I call it the electron. Is what he said. And we don't know what it is. We don't know why charge is there, but it has these characteristics, and we have a name for it, and it's called the electron. You know.
But even now, it seems like Nassim has introduced this idea that what is flowing, for instance, right?
Right.
Which is a big question in terms of space time. It's like space time seems to have this flow to it.
Right.
Is this underlying Planck? What do you call it?
I mean, there's a Planck sphere or Planck. You know, there's like a unit that's like the Lego that makes up the proton is made up of a bunch of small Planck things.
Yeah.
Plancklets. I mean, my sense of listening to him is they're spherical and they're packed in like a geodesic.
Spherical or toroidal.
Or toroidal. Yeah. True. Yeah, yeah.
See, that's the thing. It's like we don't use the language correct, right? I mean, you use throughout the word spherical.
Right.
There's a huge difference between a spherical. Yet we have a magnetosphere, which is not a sphere.
Yeah.
Right.
True.
A magnetosphere is a magnetotorus, actually.
Right.
Although actually the magnetosphere of the Earth, for instance, or whatever the field is, the electromagnetic field surrounding the Earth, is not exactly a torus either. It's a very complex, weird structure.
Sure.
So I guess.
And the Earth isn't a sphere; it's a spheroid, oblate spheroid.
Oblate spheroids,
but and like in the way he was talking about the proton too, is the proton is like doing this resonant, like standing wave, like 3-dimensional standing wave thing, you know.
So yeah, it is complicated to describe the structures, which are extremely complicated.
But like in his diagram, the proton is a spherical thing, and then all of the little Planck things that are create this 3-dimensional structure are represented as a bunch of spherical little spheres, that are tightly packed in a 3-dimensional structure.
Thing is,
in a geodesic structure.
A sphere is a static structure.
Yep.
Whereas a torus, to me, is a very
dynamic
structure.
Right.
And there's nothing static about any of this activity going on at the Planck level.
Right.
So that's why I think that to recognize that they're these tiny little toruses somehow is a much more useful model.
Yeah, and I think you're right. And right during that conversation, when I thought he was going to say sphere, he said torus shape. Like when they were talking about the shape. Yes. He very specifically chose to talk about a torus with two primary characteristics, which is like there's like the latitudinal or
the progression through the
torus rotation, and then there's the polar flow. There's like these two flows,
which we dealt with in our modeling of the torus and the monad.
Right. And it's also like, I mean, that's also like the geomagnetic field of the Earth too.
Yeah. It's like I was thinking actually of going back through because I use magnetosphere, the word magnetosphere, in my Living Solar System book a lot. Mm-hmm. But I arrived at this idea that the best word for the field surrounding the Earth is actually an electromagnetotorus.
Electromagnetotorus, nice.
Electromagnetotorus is totally different.
Yeah.
But that's exactly what I think it is, because it's like just a magnetosphere. Even the word magnet is a static word, right? It's electrostatics is more associated with that, whereas the magnetosphere is not at all a static structure. It's got that's the communication between the heliotorus and the electromagnetotorus of the Earth. And also it's like the circle of illumination is like a fixed feature of the magnetotorus. Right? It is. I mean, well, not in terms of it's not fixed relative to the axis, but it's fixed relative to the orientation
of the sun and the Earth.
Yeah. The Earth, right? So anyway, it's like, but if you don't use these correct terminologies, and the torus is a much underused word, I think, in electromagnetics and biology and all this stuff.
Yeah, I mean, I think and that resonates with what he seems like he was trying to say. Yeah. resonance, right? Is like, it seems like that was really what he was trying to do too, was shift the focus onto Taurus. Taurus is all the way down. I think they even made a joke
Taurus
about
is
that.
all the way down. Yeah,
Instead of
exactly.
tortoises.
Yeah, and that
Or
especially
tori.
it was in that other video where he was being interviewed by the she was a doctor, I
Uh huh.
think,
Yeah, yeah.
physician,
Medical
yeah,
physician.
and they were talking about the what is it the
The mitochondria.
mitochondria.
Mm-hmm.
It has a torus somewhere in that also.
Mm-hmm.
That is what links it to the 0 point field
Uh huh.
in a
Right.
certain sense. That just kind of blew my mind. Just
Yeah.
that recognition that somehow there's this transmission of force, energy across scale through these tori. Is it
Yep.
tori or
I
torus?
don't know, but I like call it saying it tori. I don't know what the official
Toris?
plural of Taurus is.
Magnetotori?
It sounds better than Tauruses.
Electromagnetotori, yeah.
Yeah. Yeah. I mean, and that what I like about that, I guess where that connects with my model of reality is that gets into this, gravity is a push idea,
Yes.
where there's all these waves, superluminal, subluminal waves going in all directions. There's this pressure. It's kind of like being deep underwater. There is a way to imagine this pressure, but that's like different in the sense that it stops at the surface. But these are waves that are passing through in all directions. And the next, like every point in space is a nexus for these waves going in all directions, basically.
Right. Every star system is contributing to this, and
yeah. And or who knows? Like star systems are in the physical, like the physical visible dimension.
Well, you're talking about like if you could see plasma or something,
right?
Like there, yeah.
Or like Nassim, like the most, like the thing that one of the highlights of that conversation with Nassim Haramein and the Demystify Sci podcast was when he went into the sub-Planck domain.
Oh yeah, right. That was beautiful.
Right, which and he was talking about these superluminal something, waves and to me that was where it was getting into this thing that was the most on point in that conversation about this idea of what is the it that is happening in all directions in every point in space is these superluminal waves or superluminal something. But and I think that is like the domain of quantum entanglement, consciousness, telepathy, psychic connection, remote viewing. This is where we're getting into the hyperspace. People who have these DMT experiences, there's kind of this developing lingo of like, breaking through into hyperspace. Hyperspace is faster than light.
Yeah.
There's, so yeah. And that is relevant to gravity because it's like that torus, and they were talking about the torus is kind of the bridge between that 0 point fluctuation and electromagnetics or everything else. And that's also true of gravity. And it's like, if it's that superluminal, super tiny, smaller than the Planck length, something happening. But we're talking about interference patterns, standing waves of those, whatever those are, that then are manifesting into the subluminous, slower than the speed of light, or speed of light is like the transition boundary between the boundary, right, is what you're right. He was saying it has to do with our boundary, our scale, the observable universe, and the Planck length are like the two boundaries having to do with the speed of light, the scale boundary.
Right.
But it's interesting too that the proton then is the particle or the thing of most stable unit. Um, and the proton then is also the most relevant thing that would then be the thing in this gravity is a push idea, that there are these waves moving in all directions. When you have two standing waves that are basically what matter is, that are then become shading each other from this energy that's happening all around them, they're going to be getting more push from all directions except for the direction that's directly between them, that's along the line that directly connects them.
Casimir effect.
And then that's the Casimir effect, is simply that these waves are pushing, there's this pressure in all directions except for the direction where those waves are being slightly diffracted or resisted or somehow are interacting with the standing wave of the proton. Right? The proton is the most basic stable unit of resting or standing wave mass of standing wave energy.
Yeah.
Those superluminal waves are subtly interacting with it in such a way that it's kind of like it's diffracting their energy so that it's shading the other proton and vice versa. They're both shading each other. Then they're being pushed together. Anyway, that's my gravity as a push model.
No, I think that the gravity as a push is it's the only thing that makes sense, really, to be honest.
But so that also is relevant to the morphogenetic field and the entanglement between the human and the planets of the solar system, because that whatever that is, we don't really have a word for that. The superluminal sub-Planck waves, right, are like, that is what is really is the thing that, it's all connected, man. That is the layer that is the connection that the magnetic fields and the on a much more macro scale are like derivatives of. They're like third order effects from this like prime relationship or prime interaction between everything. But the interaction between the consciousness and the physical being of the human on Earth, on the heart planet, is interacting with the morphogenetic field of the other planets on this like instantaneous dimension, where space is like, it crosses that space in relatively an instant. He was talking about it's so fast that it can go across the observable universe, just millions of times faster than we can even conceive of.
So tell me again so the morphogenetic field, I mean, I'm trying to get a grasp of this. I mean, I'm convinced that the morphogenetic field is the only way to explain.
Right. I agree.
Yeah.
You can't, I don't think it can be explained on the level of actual measurable electromagnetic field interaction. I just don't like.
Well,
I can't imagine measuring it with instruments that can measure the electromagnetic field.
Well, you're not measuring force. You're measuring information, or
exactly.
You're looking to measure information.
Right.
So the information has to be embedded in some structure.
Right.
And that structure, I think you're right, is that those little tori. It's like if you imagine that the tori it's polarized, right?
Yeah. So
if it's polarized in one direction or the other, then that's how you can store information, just like zeros and ones. Basically, you got this structure that can be.
And I think the information is being transmitted, so to speak, or conveyed via these sub-Planck superluminal waves.
Yeah, exactly.
Yeah.
Yeah, it's what's interesting is that you can't. It's not it's not in the magnetosphere, but it's also not out of the
Right.
magnetosphere either.
Right.
Right? It's like the magnetosphere, for instance, I was saying it's an electromagnetotorus, and the circle of illumination is a fixed feature of that electromagnetotorus. It actually provides the information for constructing the diaphragm, right? It's the
Mm.
diaphragm in a human body with the lungs above, the digestive system below.
Mm.
So, because it's such a profound difference, the the impact of light on photosynthetic plants and darkness on the other side of the earth, right? And that somehow is inherent in the field structure.
Sure. Can we take a look at that actually?
Let's draw that up.
So So you're talking about, it's probably easier to see in the chakra mode, right?
Yeah, absolutely.
You're talking about this, oops, I went inside.
Oops.
You're talking about this line that's represented by this disc.
Circle, that flat circle, which passes through the circle of illumination is a circle surrounding the Earth, which marks the light half from the dark half of Earth.
Right.
And it's always perpendicular to a line passing through the sun and the Earth.
Right.
Now,
so even though the pole through a year fluctuates around,
right.
we're looking at it from the perspective of the orientation of the Earth to the sun.
Right. This is chakra mode, where that axis, that sun-Earth axis, is always fixed vertical.
Mm-hmm.
So that's the way that the chakra, the Earth, the heart planet, and its magnetosphere is. See, the magnetosphere also will change relative to that circle of illumination, but that's just an indication then of how the biorhythms
Mm-hmm.
are inherent within the structure, right? Because there's the spinning of the Earth is the solar day, the moon is the lunar month, and then the tilt of the Earth and its magnetosphere relative to this electromagnetospheric structure here, which is another part of this.
Here, let me switch to a different view here.
Is the swara, which is equivalent to the alternation of sympathetic and parasympathetic activity in the body. So this is where physics and biology, it's like biology is actually the more fundamental field in a certain sense.
Mm-hmm.
Physics is useful to explain the biology, right?
Yeah, or when you say the biology, I'm like, biology is the study of life, but you're saying the actual life is itself more fundamental than this physics, or what? I guess I'm a little bit confused by what you mean by what you just said about biology versus physics.
Well, I'm saying that it's like David Bohm talks about order a lot.
Mm-hmm.
He had the implicate order and the explicate order.
Mm-hmm.
And the explicate order, and also the Toltecs talk about this, right? The Nahal is the implicate order,
Mm.
and then the tonal is the explicate order.
Mm-hmm.
And it's like the explicate order is physical. It's physicality. It's whatever you can name or talk about or describe.
Mm-hmm.
But there's an order behind it,
mm-hmm.
and that order is biological. It is the biology. It's the organization into. It's a modular organization. It's the chakras,
Mm-hmm.
and that organization doesn't have. There's no. It's like we were talking about. How can you mathematize that order?
Mm-hmm.
It's biological. It is. It's what's necessary. It's the creative. It's what creates the structure.
Mm-hmm.
Order is required to create structure. You can't have structure without an order to it.
Mm-hmm.
And so the original order is biological. That's I don't know.
Mm-hmm. Yeah, I think so. Yeah.
So the biology comes first, and then the physics. You can use the physics to try to explain it and describe it,
mm-hmm.
and we've used the physics to create these structures here, or a representation of these structures.
What do you mean we've used physics?
Well, to create this torus,
Yeah.
we used a mathematical, sine
Oh,
wave
just a concept. Yes. Yeah.
to
A concept of a torus to make it.
right.
Yeah.
But that concept comes from, where did the concept come from?
Yeah. From measuring and studying dipoles and the magnetic field of the Earth and
Yeah, it
yeah.
comes from what is.
Right.
Whatever. I mean, how did we didn't just make this stuff up.
Yep.
And this structure, this structure here, and the structure of a human body didn't just come out of nothing. It came out of what is, and what is a solar system with this organization somehow. For whatever reason, how did it end up here?
Yep.
It creatively somehow selected this organization. We don't know how, but somehow it did. And that's the biology of it. That's the life of it. The Nahal is life before manifestation. It's the impulse to create something that it can know. And out of the unknown, but it's alive. It can't help but being alive. Life comes first, and then it creates a structure that it can gradually know itself. Is the way that I think of it. So
yeah, that to me definitely is a well said representation of like a lot of different spiritual traditions attempting to put words to this
life
thing
comes first,
that's like hard to put words to.
So if life comes first, that means that biology, the study of life, is more fundamental than physics, the study of structure or process or
because
whatever.
structure comes out of life.
Structure comes out of life.
Yeah, interesting.
Yeah, it is.
And that kind of, speaking of Planck, there's a famous quote of him, like, consciousness is fundamental. You can't get behind consciousness, which is, I think, Planck, I think so.
Yeah, I bet it was. All those guys, all of the greats were fascinated, I think, with this underlying, where is consciousness? Even if they knew they couldn't admit it,
Yeah.
It's like, that is the fundamental question. And just wholeness, it's like when you open yourself up to wholeness, you have to open yourself up to the life. It's like we are part of the thing that we're trying to make sense of. So really, until you start to address what am I, how can you address what's out there before you know what you are that's doing the addressing, right? So really, you have to go all the way back to that original impulse of creation, which life is creating to know itself. Yeah.
Nice. And so there's a knowing there that's fundamental. That kind of reminds me of the Baha'i, there's some nice language around the divine. God is the all-knowing and the unknowable, right? So the degree to which we are able to be aware is the side of us that is of the divine origin side. The knower, the ability, the degree to which we're able to know reality, that is the degree to which we're manifesting the divine element or the divine aspect. And the degree to which we also are knowable, we are.
And the degree to which we are unknowable. Because
well, as I was flipping the other side of it, the degree to which we are knowable is more our extrinsic or the what were the terms you said? Implicate, explicate, right? Yeah. Is the object side of us, the flesh, human, with attributes. The mortal side, so to speak, is the knowable, the
it encompasses the known and the unknown.
Right. But getting at the knower and the known is to me the like that hard to put into words, but the kind of that relationship between the divine and the creator and the creation, right? Anyway.
Yeah.
But we have both, right? We have we have the spectrum. We are Yeah.
It's interesting they talk about the unknowable
Also.
because it's important to recognize that there is an unknowable.
You're right.
I think, in other words, something. It's like we're not going to figure everything out.
Right.
It's impossible,
Mm-hmm.
and the unknowable is. It's like it's unknowable how why this structure in particular, right? I mean,
Mm.
why these? Well, that's just one example. There's so much unknowable.
Well, I mean, what I think this is also reminding me of one piece of what I was trying to get at with the Baha'i terminology or the Baha'i taxonomy almost is the unknowable, the knower, and the unknowable are kind of in the same part of the map, right? It's the omniscient, and the more omniscient, the less knowable, right? It's in the same area. So it's like just the fact that we're able to know about the solar system is the part of us that is probably the least is in the department of the least knowable about ourselves. Like that's the area where we could, the more that we try to like know that part of ourselves that is the part of us that allows us to know, is where we can get into that like an interesting part of that first Toltec teaching book is when he talked about the ancient Toltec sorcerers who attempted to know the unknowable went crazy.
Yeah, right.
And I mean, there's just on the surface of it, there's an obviousness there, which a kid would be like, if it's unknowable, why are you trying to know it? You know?
Well, I think that's the problem, or I don't know if it's a problem, but there is the known, the unknowable, and the unknown.
There's the known, the unknown, and then the unknowable.
It's not obvious except for a person who can see, according to the Toltec
Sure.
tradition. What's the difference between the unknowable and the unknown?
Right.
And I think so.
And that to me that's like there's an idea of like kids who are learning. There's a degree of having to find out where the boundaries are in order to know where the boundaries are.
Right.
Like you have to discover them to some degree, you know?
Yeah.
Yeah.
And I think it's like I'm curious about dark energy, dark matter.
Mm.
Is that unknowable or is it unknown? Because if you're saying that I think you would go with the idea that it's unknown because we have characterized it in an incorrect fashion. In other words, if it's true that it's a misinterpretation of the redshift, right?
Yeah.
Then it could be known.
It's derivative of a story used to explain the redshift.
Right.
We've had to then create these other layers of story to explain other consequences of the first story, which is the Doppler shift story.
Right.
So saying that it's unknown, I would say the explanation for why the redshift is unknown. It's not unknowable.
Not unknowable. But
Yeah.
it's possible it is unknowable, actually. In other words, that all of our models attempting to explain it will never actually
Explain it
or come close to explaining it.
Well, I disagree with that. I think, well, it depends on what you mean by what it is that's knowable or unknowable. Like, I don't think I can explain what I mean by that.
Yeah.
What I love about what Nassim Haramein is saying that is actually, to me, substantiating my opinion about the misunderstanding about the redshift.
Yeah.
Is like he's very much about we can't get rid of the infinities, you know, but
That was beautiful, huh?
I love that. It's necessary to keep them, but understand them in relation to the scope that we're looking at from, right? And and I would say yes, I think the explanation for the redshift is probably unknowable in the realm of like, what is a black hole really? You know, like if there's a black hole at play in what is shifting the light on some level. And if our what we mean by the cause of what's shifting the light is unknowable, well, yeah, if it gets into like, if on some level there's just this black hole at the center of every particle and at the center of the galaxy, explaining that might be impossible. But I do think we can come up with better equations, a better model that models what happens to light over long distances. That is a different model than a Doppler shift model, of everything's moving away from each other at an accelerating rate. That's a bullshit model. I think we can come up with a better model that doesn't have galaxies moving away from each other at an accelerating rate in a but then terms, right? In a simplistic definition of what space is, right? But yeah, okay, they are moving away from each other, but we've got all of space is in spin and in spin, and so the actual path that beam of light, that one little speck of light that reached us from that redshifted source, that wasn't a straight line, right?
Not even close.
Not even close. And the degree to which that line, that speck of light took to reach us, and the gravity or the singularities that it interacted with on the way to reach us, we can model that without explaining what the singularity actually is. We can come up with a more accurate model that describes that path and that explains that redshift using a more accurate, descriptive, understandable, intuitive model.
You're looking out there in space,
yeah,
and you're seeing, okay, this is empty. I can't see anything except the stars, and so I'm assuming that the light from that star is traveling in a straight line from here to there.
And that's what our current model is.
That's the current model.
Yeah.
You're saying that no, there's what the space that we're looking between us is actually filled with undulations,
plasma,
magnetoruses, and plasma flowing in different.
And big G gravity, big G constant gravity. Like what Unzinger is focusing on is like, look, you can't just have these two objects floating in imaginary empty void with no reference frame, and you pick your reference frame. There's no preferred reference frame. Carver Mead's talking about how, the thing with the three you do a laser interferometer, I think it's called. It's basically like a 3-axis rotational thing.
Yeah,
you split the beam of a laser into two directions. You run it through a fiber optic coil, rejoin them, and you have a sensor that can measure the phase shift. And as you turn this thing, it'll as you turn it through a 360 degrees, it'll do a full phase shift from one wavelength where the two wavelengths are synchronous, and then as you turn it 360s, they go a full out of phase and then back into phase 360 degrees later. And so if you put 3 of these in the 3 different axi, what Carver Mead is saying is like, this is like such a fundamental experiment, fundamental data to prove that there is a preferred reference frame. If you just let that sit for a full day on a table, it will go through a full rotation.
Oh, like the pendulum proving that the Earth is
spinning, or like the bucket experiment. It's proving, the bucket experiment proves that there's this other big G mass out there that water is interacting with. That's not just Earth's mass. And what this Carver Mead's 3-axis fiber thing is proving is that there is a reference frame, which is the gravity, the mass of the universe. Like this little you could bury this thing in the ground, wherever it is, it's interacting. Go ahead.
But does that mass, the fact that it's mass, we're so used to being able to see mass, but is it possible that there's a mass that we can't see that is contributing to the big G, for instance, right? It's like I look at the solar system, for instance, and I think, okay, if the solar system's alive, we're alive, the solar system's alive, what's the next scale? The galaxy, maybe, right? So if the galaxy is alive, then what's the next scale? The metagalaxy, or
All the way out to the boundary of the observable universe.
But something is constraining these living structures like a skin.
Mm-hmm.
And it's not just gravity, I think. I don't think gravity alone is possible. It's like...
But gravity is a shadow of this subplonk, the sea of subplonk superluminal waves that are moving in all directions.
Gravity
and
is a what?
It's a shadow.
A shadow
of this pressure, like all directional pressure wave or waves. It's like, and that is basically like, what is mass? Like Nassim Haramein has basically been able to define the mass of the proton in terms of these smaller, of the 0 point fluctuations.
Yeah.
Like his equations have now like proven that there's this direct relationship between, E equals mc squared, whatever type of a equation, where it just describes the proton mass, which is like our fundamental thing of mass, observable mass.
Yeah.
Is the proton.
Yeah, the monad of
mass. And that's described in terms of these 0 point fluctuations, right? And that's the informational, that's the thing that's conveying the information and conveying the interaction with mass of the universe at every point in space-time, like, which is why that little Carver-Mead's 3-dimensional laser interferometer is interacting with the mass of the universe.
Somehow, though, I still think...
But you're like, let me ask you a question about what your statement. You said, what if there's mass that we can't see?
We'll never be able to see.
But it depends on scope. Are you talking about within the scope of the observable universe, or are you including all of the conceivable mass?
Within the scope of the...
So let's even say like there's confusion around the model of the galaxy with current models. It doesn't make sense how galaxies are being held together,
right,
based on our current erroneous definition of mass and gravity and all that. And so therefore there must be this dark matter that's there, that's holding it together.
Right.
Yeah. Is that the kind of what you're getting at?
Yeah. No. I'm just saying that if there is an unknowable.
Yeah.
Right. That it's possible that it's like I think we don't like the idea of an unknowable, and so we try to find solutions to something and just assume that it's knowable. We just don't know it yet, so it's unknowable.
And my response to that is, I think the better model of the redshift would be a result of bringing the infinity back into let's say, like, what is all this plasma between here and there? There's a lot of unknowable in that, and like bringing the infinity, bringing the singularity back into every single part. What Nassim's trying to say is there's actually a wormhole, black hole, whatever, in every single proton. And on a below the proton, on this like the pixel, the fundamental Planck pixel of space, like there's a massive amount of information, energy, force, structure, symmetry, like tension communicated across space, where there's no like observable stuff there, observable proton mass, right? But there's definitely a substrate of something that is communicating structure and symmetry across.
Gotta be.
Yeah.
Yeah.
And to what degree does light transmitting or moving across that space interacting with whatever that is? Like, is that a completely non-reactive thing, or is that just interacting with all of the mass, like just saying that interacting with all the mass of the observable universe? If we shift our definition of mass to be every single particle of mass is actually a black hole wormhole, that gets a lot more like, holy shit. There's a lot of mystery there. And we don't necessarily have to explain the mystery of what a wormhole black hole at the center of every particle of mass is to come up with a better model or equation that accurately describes light moving across that space that would describe its non-straight line movement. What do you think about that?
Yeah.
Without discovering some other invisible mass thing other than the protons that are there. Does that what I mean? It's like what I think what Nassim's doing is he's changing our model of the proton to be more descriptive. Like he said, like the current mathematical model only describes 1% of what we know a proton is, and his model is explaining 100% of it. And by doing that, you're filling in like 99% of the description of why a proton has mass. That fills in that drastically changes the model of what a galaxy's mass is, using the existing things that we know are there, but filling in the picture of the degree to which they are influencing or having a role to play.
Yeah, I gotta admit, what you said about the 1% to the 100% thing, I remember him talking about that, but I'm drawing a blank actually.
Yeah.
For whatever reason. I need to go back.
I kind of want to watch it. Shall we watch it and react to it? Have a reaction video?
Let's do that next week.
Oh man.
Yeah, no, I think we got a lot of other things to do.
All right.
But,
all right.
I'm still though. I guess I'm still convinced based upon the Toltec stuff, which I just recognize so much wisdom there.
Absolutely.
That there is an unknowable.
I totally agree.
And that it's a significant proportion of the tonal, I guess, in a certain sense.
Well, so to me, the perfect example of that is Nassim putting a black hole at the center of a proton in a wormhole. Like, is not that actually restoring this in a very dramatic way the Nahal into the very center of the tunnel, which is the fundamental particle of mass?
Yeah, the Nahal has to be everywhere if it's in,
right.
Yeah.
I mean, to me, that is like the prototypical example of what you're talking about. Changing the model from only being able to explain 1% of a proton's mass to being able to describe 100% of its mass, and the source of that explanation is coming from the Nahal, in the sense of it's this sea of superluminal subplank waves. Like, that's the closest definition to the Nahal at play in the observable universe that I can conceive of.
Well, if you can conceive of it, it's not the Nahal.
Well, I said closest.
Yeah.
It's like the boundary condition between the knowable and the unknowable.
Yeah. Okay. Yeah. That's true. Actually.
And is the cause of the electromagnetic torus of the Planck, the sub-proton Planck units, pixels, and therefore the electromagnetic torus of the proton itself.
it's driving me crazy, this thing about the 1%.
If we could find it, let's just do a little
Really?
quick. Yeah.
All right.
Come on. I'm gonna pause. Whoa, here it is. In Nassim's, I'm moving the
Gravity. Is it where? What?
in Nassim's video,
26.
The Origin of Mass and Nature of Gravity. He's got a frame here. Screen mechanism at the hadronic scale. Gravity as a pressure force. That's the gravity as a push. Or I would say the consequence of the push. It's the shadow of the push. The 0 point fluctuation is the push.
It's the apparent gravity of the.
Yeah, right. It's the. All right. Pause. What were we saying about? Welcome back. Resonance.
What was I saying? Well, this is out of context a little bit for our
That's
viewers
fine.
here, but
We're jumping.
well, we were talking about this Nassim Haramein and the creation of mass and everything, and angular momentum has a center, and the radius involved,
Mhm.
and that brought up in my mind the Toltec teaching.
Mhm.
Teilhard Merez talks about that there's two types of awareness. There's inherent awareness, and there's evolving awareness.
Mhm.
And inherent awareness it's fixed relative to a center.
Mhm.
So things progress in circles relative to that.
Or monadic.
It's monadic, but there's also evolving awareness, which is where that inherent awareness is moving along a timeline. Right? So somehow, I don't know how.
Yeah. Hey.
It seems to be related, actually.
Right.
Yeah.
And I mean, this also brings up. This is riffing on something that obviously we're not including. This is a question that came up listening to his talk and viewing a few of his other videos, but around this voxel, this smaller
Planck spherical oscillator.
Yeah, the Planck spherical oscillator. Did we? I don't know if we can bring it up quickly here, but there's the foam. There's the source of it, but that right there, I love this image here. The voxel is the
fluid, similar to the quark, gluon plasma fluid dynamics.
Planck plasma flow. That's the inherent awareness right there. Oh wait, no, that's the evolving awareness.
But like these little voxels, they're describing as coming into and out of existence.
Often associated with the quark epoch of the early universe. We describe the granularity or
like right here.
Disappearing as creation and annihilation cycles. This results in an interstitial space-filling symmetry. The first screening of the vacuum fluctuation. We note that the space-filling nature of this computation must be kept in the context of a dynamical foam of spherical bubbles appearing and disappearing as creation and annihilation cycles.
So like that idea, so these voxels, these little spherical oscillating tori
Yep.
are like, they're not a thing that persists. The proton is like what he's trying to say is the proton is kind of the smallest Lego brick of consistent thing that sticks around for billions of years.
Yeah.
And I'm reminded of the conversation where they were talking about perpetual motion. Like this is like a thing that is a perpetual thing, and it's continuously just vibrating there, like that's. But in any case, so in this model, there's all these smaller Planck spherical tori voxels, like the pixels of space, that is what the proton is composed of, so to speak, or a way to like map out space on a smaller than proton scale. And so my question that I think is answered by this is, if a proton is moving, like to what you just brought up, there's like the inherent thing of, okay, here's a proton, but then we also have this idea of it moving across time or across a timeline. That proton that's moving, what's happening like I was thinking like, okay, are these voxels moving with it?
Yeah, is
Are
it
these
displacing things like a swimming through water, or is it
right? Or
actually reassembling itself as it goes along?
exactly. And like what this is suggesting is that these little voxels are blinking, like these are just momentary um, imbalances in this polarized
Exactly.
sub.
There would have to be some conservation law, basically, right? So that it's like the
Right.
yeah, so that you can you can have dynamic, but something that's also static, which is
The momentum
the momentum
over
of the
timeline. Yeah.
right,
Yeah. Momentum of
rectangular momentum or whatever the momentum. Yeah,
right. And then so that proton moving is like that wave that's moving, right? In a sense, a
moving wave,
standing
right?
wave. The standing wave is moving
Yes.
because a force that would be exerted on the proton to accelerate it from, let's say, relative from this position where it's sitting, let's say, stationary,
Yeah, stationary proton.
and then something causes it to move, that something would be transmitted would be some kind of energy wave moving through the sea of Planck spherical oscillators would be the mechanism, the thing that the matrix, the ether.
But how does mass emerge out of this? So that was our original
Yeah, yeah.
thing that we were getting to.
And right, how does mass emerge out of it? And the idea was that his model describes 100% of the mass of the proton, and does that simple act change the model of the mass of galaxies such that they stick together?
I know we got to find that. I need to be reminded again about
The 1% versus the 100% of the proton. Well, I think this. Oh yeah, let's go back to his verbal explanation.
Right there, you had that.
Okay, currently
Proton mass calculation
of the electromagnetic field inside the cavity of the proton to see if we get anything valid, like you know what the correlation functions are, right? Like they're equations that tells you how many waves are canceling out and how many waves are creating standing waves of energy. And so you can calculate with these equations in the field of wave interaction with all the modes of interaction. You can calculate. Here's the hic: if you renormalize at the Planck scale, if you say, okay, my Planck scale is my smallest wave, all the other waves, how inside the cavity of the proton, so you have a limit on the larger waves as well, right? Because you're inside the cavity of the proton. How many are going to cancel out and how many are going to be constructive? And when you do that, guess what you get?
The wave function of the proton?
Mass of the proton. Yeah, the exact energy of the proton, the exact mass of the proton. Not approximately, the exact value.
So wait a minute.
Now, just to compare this to QED.
Yeah, here we go.
Currently.
But you were about to say something?
Well, he said the exact energy of the proton, then he said the exact mass.
It's the same thing.
And
that's what she said too, was the wave function. These are all E equals MC squared. This is all
that's
related.
Exactly what he's doing. So he's actually determining the energy based upon the wave functions.
Right.
Passing through a particular location.
But he has a more accurate wave function equation because you're normalized on those scales, right?
Okay.
This is my understanding.
Yep.
Again, not being, I can't read that math behind him, so.
The mass of the proton is predicted by 1%.
Okay, let's here. Here we got it.
Exact value. Now, just to compare this to QED, okay, currently the mass of the proton is predicted by 1% by the Higgs mechanism. So the Higgs mechanism, with all of its glory, is only able to predict 1%
Dude, you did it.
of the mass, the proton. Okay? Well, 1 to
Nassim.
5%, they're unsure because it's not very precise. Because all of QED and QCD is curve fitting renormalizations everywhere, new fields. And so what they've done is they sliced the electromagnetic field and they said, okay, for each particle, we're going to add a field. Okay? And now you have quantum field theory and QED. And now you get like this idea.
Which is like, I think my understanding of what he's getting at, and kind of what we were talking about earlier. You said something about quantum mechanics is dealing with like Schwarzschild points or something, right?
Yeah.
And so what he's saying is they're like subdividing the proton, and within each area they're ascribing a point and a field to each layer, and then somehow trying to sum all that up and do a bunch of like complex point field probabilistic stuff, and they're arriving at 1% of the mass. That's my understanding of what he's talking about right now. The problem with QED.
Yeah, I kind of got the sense that he was talking about a renormalization within the Planck scale and the size of the proton, right?
I think so.
But then also maybe he's talking about if you were to extend the scale up incrementally to account for different structures
outside of the proton.
Yeah.
I don't think so. I think he's my understanding of what he's saying is he's describing how QED is attempting to derive the mass of the proton using QED. So he's like, when he's talking about subdividing, he's subdividing within the space of the proton, not outside. Is what I'm is okay.
That like
here, I'm going to back up.
New fields, and so what? 1 to 5%, all by the Higgs mechanism.
Okay.
So the Higgs mechanism, with all of its glory, is only able to predict 1% of the mass, the proton. Okay? 1 to 5%, they're unsure because it's not very precise. Because all of QED and QCD is curve fitting renormalizations everywhere, new fields. And so what they've done is they sliced the electromagnetic field and they said, okay, for each particle, we're going to add a field. Okay? And now you have quantum field theory and QED. And now you get like this idea that like every field has a particle is carrying a particle, and every particle is carrying a field. And these fields are literally like pulled out of nowhere. Like it's really smoke and mirrors. and so it's self-consistent inside the standard model. It's self-consistent inside the standard model, but applied to the real thing, like the mass of a proton, you're missing 99% of it. Okay? And then the other 99% that's missing is attributed to various mechanism in QCD, in the strong force. So the color
like the kinetic and binding energies and things like that.
That's right.
What?
Exactly. So it's the glue
Oops, I accidentally fast forwarded
with the
here.
quarks that produces the energy with that to various mechanism in QCD, in the strong force. So the color force,
like the kinetic and binding energies and things like that.
That's right. Exactly. So it's the gluon field with the quarks that produces the energy from this, for the rest of the mass, the proton. But when you look at these equations, it's hand waving. It really is. It's not fundamental. It's not like it's nowhere close to being a fundamental theory. Any physicist that's honest about it will tell you it's a way to calculate that gives us approximations. We run supercomputers for years that cost billions of dollars to run for these calculations. And at the end of it, we have approximations.
Is he talking about?
That's the loudest, by the way. It's like these simulate.
Is he talking about like QED is the standard model has all these subparticles, right?
Yep.
And the subparticles have a mass associated with each one of those subparticles,
I think so,
right?
yeah.
And if you were to add all that up, is he saying that that's what generates the 1%?
That's my understanding of what he's saying.
All right.
And you think about, then this is deriving again from another part of their conversation. He helped me understand.
That's why you needed the Higgs particle to
right.
make up the difference between, they're looking for this
right.
particle that accounts for the missing mass.
Right.
Okay.
Yeah, and an additional part of the story to help understand what, the standard model is all of these subparticles, gluons and leptons and all these things. And I'm also deriving this from something he said in this conversation, which is about those particles are coming from smashing protons.
Right. He's talking about how a car, you got to
right.
You smash these two cars and then you bring these things out.
Have all these little pieces flying around.
Right.
And but a really important thing of what he said is, sure, you can, so we smash these things, we measure all these things flying out in different directions, and then we kind of attribute mass to them because they're like spinning around each other, right? There's like a degree of orbit of these spins, and spin right, spin left. Like there's a labeling of all of these different little bits and pieces flying and spinning and having like gravity interactions between each other.
Yeah.
And so, so these different quote particles, subparticles have mass effects, but the really important point he made is none of them are stable. They all disappear back into the background. Right. So they're you could even say, like, to me, what I hear then is these are like ripples on the water, or ripples, of breaking apart the standing wave. You're going to have all these subwaves like moving out, and the spin or this quote unquote particle moving out is just you have two different wave patterns that are intermingling.
Yeah.
They're just these little interactions of waves.
Yeah, they're meaningless.
Yeah, they're meaningless, really, fundamentally. And which I think also gets back to this, at the level we're talking about, at the proton scale, mass is just a standing wave. Just is simplifying, obviously. It's a three-dimensional standing wave. Like that proton is, it's like all these little oscillators. Like the proton is just the like higher order standing wave of this like background. He called it's the something equation. That is how he derived the mass of the proton. And it's this thing that's described, it's equations that describe all these interacting, the 0-point fluctuations.
Yeah.
And at all these different frequencies, wavelengths, they're there across all these different wavelengths, all simultaneously going in all directions.
Within a frame size.
Well, the point is they are within all there. It's of all scales,
but
he limited it, and that was the key.
That's what then allowed him to.
Right.
Yeah.
But just thinking about it is like those waves are at larger wavelengths too, larger than the proton. It's just by limiting the scope to the dimension of a proton, the mass of the proton exactly equals the energy of waves, of the 0-point fluctuation waves within that wavelength range between the Planck length and the proton, between the Planck radius and the proton radius.
Yeah, that's pretty amazing.
And that is what mass is. is a standing wave of those, and that has inertia. Like sorry, that's I'm trying to get rid of like the words like obviously and just think about it.
Throw the word just out.
Right. That's the Mr. Know-it-all thing, you know.
Right.
But yeah, a standing wave has inertia. Similar, and yeah, that's reminding me of how a coil resists changes in current. Like you have a wire with a coil in it,
Yeah.
and you've got a current flowing through it. It has resistance to building up a current, and once a current's flowing, it resists the loss of that. It'll keep that current going too.
Well, yeah, it's because it's generated a standing wave there that has
has inertia, or has momentum, momentum and inertia.
almost like mass.
Almost like mass.
Inertia, right?
Wow.
Yeah.
Interesting.
Listen to this. This is in this Bone book again.
Okay.
You ever heard of this? The Hamilton-Jacobi theory?
No.
Yeah, I hadn't either. Or if I did, I certainly didn't remember it as being memorable. Apparently, this was the Hamilton-Jacobi theory was developed in the late 1860s, presented a new way of treating motion as based on waves rather than as particles. Let me see. Indeed, that William Hamilton had already unfolded the essential similarity between particle and wave, which is implicit in this metaphor by considering a ray of light. This is basically a form of waves. It has a trajectory resembling that of a particle, right?
Mm.
So in a sense, they're kind of saying the same thing here.
You subdivide that
subdivide
spherical event horizon into a bunch of little different rays.
That's the equivalent of a particle.
Yeah, absolutely.
Yeah. So it's like to obtain this is necessary to consider a wave packet.
Wave packet.
The wave packet therefore suggests a model of a particle that is based on the wave concept. When this is done, the theory yields both Einstein's relationship, which shows that the energy of a particle is proportional to its frequency, and de Broglie's relation that the particle's momentum is inversely proportional to its wavelength.
Wait, say that last sentence. The particle's what is inversely proportional to its wavelength? Energy.
The particle's momentum is inversely proportional to its wavelength. So somehow all of this is it's like the waveform is being translated as energy, which is being translated into mass based upon a what do you call it? The array of light instead of it's like so it's not it's kind of a ray though. It's like it's a just a particular segment of the electromagnetic.
And this is reminding me too of someone was, and I don't remember where I got this, but someone was saying, referring to the double slit experiment. Yeah. You know, which is the classic experiment talking about how light is both a wave and a particle, or characteristics of wave and a particle. They said if you have like in water in the ocean, if you have ocean waves which have white caps on them, you know, you could think of the white caps representing particles. Yep. If there's a white cap, and a white cap, if it's like an individual particle like white cap, that would be where two different, slightly different waves are slightly overlapped, but not fully canceling. Right. There's like an interference pattern there. Yeah. And the white cap, like an individual white cap, would be right where there's two waves intersect. So they're not like fully canceling. They're not fully, like if they were fully aligned, it would just be one wave. They're slightly offset, and then there's a particle right there. What they were saying is that if those two waves were to hit a seawall that had two slits in it, like a double slit experiment, the particle would disappear at the wall and reappear on the other side of the wall to match exactly the double slit experiment, where you've got these little packets that are hitting the film that add up to like a wave-like characteristic.
It also brings to mind in my head just the idea that it's like you've got a single waveform, you know, it's doing this sort of thing. Mm-hmm. And if you were to visualize that as a standing wave, you've then got a circle in a certain sense, right? Right. But if you have another one coming in from the other angle, then you've got two circles at right angles to each other, which generates a sphere. It's like it just brings an added dimension to the standing wave, creating particles. Right?
And the electromagnetic field is exactly two different things that are 90 degrees right angle to each other, but are three-dimensional.
You couldn't have it face-to-face, or it's like it has to kind of come in at the 90-degree angle almost.
Right. And maybe it's most stable. Maybe there's a relationship
Of course it
there
would
that's
be, yeah,
most
but it
stable,
is, yeah.
and that at other angles it will either degrade or it'll run into one that is more stable, i.e., a proton or a,
Yeah. Good stuff, man.
And like Carver-Mead is talking about, of like electromagnetic fields are interactions between stuff. There's stuff at both ends of that interaction.
It's
you
like
know?
a guitar string, you got to have something at either end.
Yeah. And what I love about his description, there's this thing of the time cone, and the entanglement experiments prove that time cone, there's like this mysterious connection that gets formed forward and backward in time from sender and receiver. And the only way to explain it is that there's a time cone of going forward and backward in time.
For relativity?
For entanglement.
Entanglement?
Yeah. That the
I've never heard of a time cone with entanglement.
There's a time cone with the propagation of light.
But that's at the speed of light. Not entanglement is instantaneous, right?
Yeah.
Is that what you're talking about?
The entanglement is theoretically instantaneous, but all we've done are experiments that were limited to studying and measuring electromagnetic fields, which are speed of light. But the thing that's important about the quantum entanglement experiments that got the Nobel Prize is they were measuring electromagnetic fields and proving that there was some interaction that was faster than the speed of light. Well, what I call faster than the speed of light, but which Carver-Mead described using the language of electromagnetics, which is limited to the speed of light, that there was a time cone. There's something moving from the receiver to the sender backwards in time to set up the resonance, to set up the relationship between sender and receiver that would only work when the resonance was, when there's a filter in between that's spinning. And the only way for the particle, the electron, to move from sender to receiver is if there's reverse in time communication. And the only way that that's possible is if there is something which, he didn't have, there's no language in the accepted terminology for some other, symmetry being communicated faster than the speed of light. And that's why, from after hearing Carver-Mead describe that experiment on this Demystify Psi podcast is when that's the first time I felt like I understood the experiment well enough to be able to there's a model there.
No, you say that there's no model, but there is another model, which is described in that book up there, the Marvel of Light.
Okay.
Which is to assume that the vacuum of space is actually a rigid transmitter of force.
Right. So the longitudinal waves.
Longitudinal waves.
Yeah.
So in other words, assuming that there's a tension between two sources that was established maybe at the speed of light.
Yep.
Once the tension is established, then transmission is instantaneous.
Mm-hmm.
If you move the end of one rod,
mm-hmm.
assuming that rod is rigid,
mm-hmm.
the other end of the rod moves instantaneously with that. There's no transmit. You don't need any cones of light or all this other.
Yeah, and I mean, you could even drop the established at the speed of light, because if there's something there that can transmit something at the, then it's
True.
just there is something that is communicating. There's something there that transmits or expresses or.
It's hard to abandon that speed of light, man.
Right. I'm totally okay with it. I mean, that's why I loved, there was this paper by E.T. Whittaker that came out around the same year as Einstein's first special relativity paper, where he was suggesting that, electromagnetic potential or electric potential, the vector potential field, is maybe the derivative of two interacting superluminal waves, you know? And then that's kind of like this idea of these two waves moving, and then that particle that's moving in this direction, like, how is it? These two waves are moving in this direction, and then that particle's moving in that direction. You know, there's this interference pattern.
Yeah.
And maybe that's the only thing we can measure or sense is the interference between these two other waves. And those two waves might be moving at a different rate. What is the relationship between these two waves moving at an X and Y rate, and then the particle moving at a Z rate? I bet that's slower than those other two waves
But the
within
particle
there.
doesn't necessarily need to move. If the it's like you're describing waves coming together towards this one place.
Yep.
If the source of those two waves is stable,
Mm-hmm.
then wouldn't you form like a nexus there?
Yeah, but it would blink in and out of existence, because the where the two waves meet.
Yeah.
If both are stable and you're looking at one location, those waves will crescent, and then there'll be periods where the white cap is there and then the white cap isn't there. And that, I think, is describing what those voxels, the Planck spherical, what did that other?
Yeah, no, I wrote it down here.
Like that you.
These things, the
Planck
Planck spherical oscillator.
Yeah.
Those are being described with this little, oops, let me turn on the,
H bar, Einstein-Rosen
Possibility as a result of the quantum structure
oops,
of space-time.
dang.
Einstein and Rosen can of a diameter of the Planck length and Planck mass energy are organized in a Planck plasma fluid similar to the quark gluon plasma fluid dynamics, often associated with the quark epoch of the early universe. We describe the granularity or discrete structure of this Planck plasma fluid with space-filling voxels of PSUs. We find that such space has an equivalent energy density of the quantum vacuum fluctuation. We note that the space-filling nature of this computation must be kept in the context of a dynamical foam of spherical bubbles appearing and disappearing as creation and annihilation cycles.
Appearing and disappearing as, that's what we're talking about, the waves in any given.
So what makes a proton stable then? How come it's not appearing and disappearing?
Oh, well, now that's a whole other story. You tell me, Keith. If you're so smart, Mr. Smarty Pants.
Check this out. What is this? Screened energy density.
How do I get rid of this sidebar over here?
Well, yeah, you gotta just hit on the full screen.
There you go. Theater mode. Yeah, so anyway, what were we talking about before?
Biology is better than physics? Is that?
Oh dear, trying to get controversial. I got to stir up some views, huh? Stirred some rage bait.
Right. Yeah.
All right. Was there anything? I don't think there was anything more here we wanted to look at for right now, right?
I think we covered it. I don't know if we covered it, but we.
Proton mass calculation. I just wanted to. Did he finish his thought? Yeah. Because then, the host was then talking about that's the matrix thing and getting into QED and QCD. But yeah, that one little section, what was it? The
origin of mass?
The origin of the mass of the proton.
Yeah.
Anyway, yeah.
Crazy, huh?
So good.
Yeah, it's new era in physics almost. What does this mean for?
I mean, this is why Carver Mead has been saying the last 100 years will go down in history as like the dark ages of physics. Like this whole QED, has been just like complete idiocy.
Model? I mean, I guess the standard model. What the fuck?
It's just looking at all these little pieces of blasting, and there's now like an effort to build an even bigger linear accelerator.
I mean, the standard model is curious in the proportions, right? It's very curious. It reminds me a bit of the proportions of Teilhard Merez talks about he has percentages for the known, the unknown, and the unknowable. And I often wondered if there was a correlation between his percentages and the standard.
Ooh, that'd be fun. That's a fun thing.
Yeah, I
mean, to some degree, doesn't it seem like spending the millions or maybe even billions, I don't know what the number is, of dollars on the collider and Large Hadron Collider. Don't get me started on the whole fraud of the international banking cabal money that's funding all this crazy bullshit. No, not that. Like how much money on basically smashing particles together.
They said at one time that discovering a new particle would almost guarantee you a Nobel Prize. But then at a certain point,
there were so many. Right, fine.
Nope, can't have any more particles.
Yeah.
Go away.
Yeah, I mean, if you just see it as like identifying different pieces of the car smashing and flying in different directions, like each direction
have some significance, I mean, it's got to have. Doesn't it have some significance? I mean, because
it justify your statement.
Well, I mean, the percentages are fixed.
But the question is, don't they add up to one, which is the mass of the particles being blown up?
Yeah.
Okay. And don't they add up to the momentum of the thing being blown up?
Well, look, if you want it to be practical, then yeah, you could throw out the whole thing, right?
I think this is why, what's her name? There's a Sabine Hossefelder, who's a YouTube podcaster, science podcaster, has gotten in a lot of heat recently because she wrote an article that got published in Nature where she's basically calling out the theoretical physicists for like, look, this has been going on for so long. There's so many, salaries that have been paid from this, but come on, we got to admit that there's no there. And she's been getting hammered for that.
Just the whole idea of smashing particles is so opposed to the whole concept of holism, which I am convinced if you don't incorporate holism into your physics or biology or whatever you're studying, into your study of reality, you're wasting your time and money.
Yeah, and I think it's way easier, way less expensive, and probably way more productive to just study resonance. And in fact, that is precisely what Carver Mead did and he describes it in his book, The Collective Electrodynamics, where he basically said, like, one of the benefits we have now that Einstein did not have is we have like at least 10 different macro scale coherent things that have quantum properties.
Didn't Einstein have the Bose-Einstein condensate? Or
no, that was a theoretical thing. They had nothing,
really?
As far as I know. Yeah, that was actually...
He predicted that without being able to generate it.
Yeah, that was not based on experimental... As far as I know.
Yeah.
Because this is just based on my understanding of what Carver Mead was saying.
Yeah.
Is like if Einstein had the number of coherent quantum expressing things that we can experiment with now, he would have been in a whole different place with his theories. But what Carver Mead did is he started with a superconducting coil and was able to show this, like what you were talking about earlier of a circle.
Yeah.
He was able to show that and derive that fundamental equation of current, and then was basically able to then arrive at all of the same answers as Einstein for all these different things, using what he called engineers math rather than, physicists math. And I don't understand even that math well enough to understand what exactly that meant, but I think it just meant using vectors and vector calculus and like kind of simple stuff. And so, but what he was, so he was basically saying, I forgot how I got on that, but he was saying like the dark ages of physics has been the last 100 years of this. Like, oh, right. And in another story he says about this is the guy who invented the laser.
Yeah.
I forget his name. Lazenby or something? Oh, no. Yeah, I don't remember.
Yeah.
That when he talked to Niels Bohr and I forget the other guy, like the giants of maybe whoever he talked to, he shared his ideas about the ideas of the laser, and they're like, no, that'll never work. Okay.
Didn't he?
I don't know.
Yeah. Maybe.
I haven't bothered to know because it hasn't seemed important to me. Right. It hasn't seemed relevant to me to know.
Yeah, the laser. Who cares about that?
But this is the inventor of the laser. His name is what?
I think it was Dennis Gabor.
Okay.
I know he wrote a book about it. Maybe he didn't, but
okay. Yeah. Well, supposedly, according to Carver Mead, he shared his ideas with the QED guys or the quantum theory guys, and they told him it wouldn't work, and he didn't understand quantum dynamics or quantum mechanics, because it's all particles. It's all these little,
Who is this?
This is the guy who invented the laser. Talked to them about his ideas before he actually built it.
Yeah.
And he went ahead and built lasers successfully.
Oh, yeah.
And it's all based on waves. It's all based on coherence of waves and equations of waves. There are no particles in the theory of it, And that's another example that Carver Mead uses to show like this has been the century. But I guess this, to me, getting into something I was talking about earlier, which is it really seems like there has been a lot of money spent to keep us distracted on pointless dead end baloney. The collider, the particle collider being a big one, and to what degree, and like on one of these forums, one of these, like the comment section of YouTube videos with Nassim Haramein stuff, someone made the little blithe comment of like, oh yeah, but the private military contractors are like decades ahead of this, because the question is the massive amount of money that's gone into like distracting the public with baloney garbage stuff. A lot of money has also gone in the private domain into building technologies that are out of the reach and in the dark, in secrecy. Yeah. That are all about reinforcing the secret power and not the people's power. So,
yeah, no doubt.
Yeah. Anyway, not to get political or anything. I didn't name any names.
No.
But Bitcoin is the answer.
Bitcoin.
Thank you, Satoshi Nakamoto.
Yes, indeed.
Shall we end here?
I think that was a heck of an interesting conversation for me, anyway.
That was good.
Everybody else liked it.
Ideas that resonate, maybe.
We'll see.